Hi guys, let's do this question, and first I read it. Use the method of undetermined coefficient to solve the equation below, given that when t is equals to 0, x is equals to 0 and dx all over dt is equals to 4. And guys, here is our differential equation, which shows that, guys, this is a second order because it has, actually we are supposed to have even a 2 here. I've omitted a 2 there, guys. This is a second order differential equation. So guys, let's go into it and do what we can do. So guys, I've already written something here, and what we have is our equation. The equation is here, and now guys, we are going to do this equation. We have the condition, and before that we have just a few notes here whereby we say complementary function. The solution of this equation consists of two solutions, which are called, one of them is complementary function, abbreviated as CV, while the other is particular integral, abbreviated as PI. So when you add them together, guys, we get complete solution. And guys, the complementary function is given by x subscript 1, and this is what we are going to start with, guys. So for x subscript 1, guys, we have a still in this equation, whereby, guys, we are going to write the equation once again, and this is how we are now going to write it. We are going to write as d squared x. Now this is going to be x1 for the first solution, all over dt squared plus 4 dx 1 all over dt plus 3x 1 equals to, now for the first solution, guys, is supposed to be equated to 0, like that. And this is the solution of a quadratic equation here, which has been modified now to be second order differential equation solution for complementary function. So guys, we can replace that one with what we call lambda squared plus 4. We replace this one with lambda plus 3. This is equals to 0. So guys, we are supposed to solve that equation, and it's solved by quadratic means, by quadratic methods. One of the methods, guys, I can leave you to do that, but the solution is going to be lambda equals to -1 or lambda equals to -3, like that. After doing that, guys, we can now write our initial, that is our complementary function solution. x1 is supposed to be given by this equation, that is a e raised to -1t, there is a 1 there which is represented by that, plus b e raised to -3t. So guys, that is the solution, and this solution is from the general solution written as x1 equals to a e raised to lambda t plus b e raised to lambda t. So lambda represents the solution of the quadratic equation, just as we had, guys. So guys, we continue now. We go to the second solution, which is called particular integral. So we write pi like that. And now guys, when we come here, we shall now deal with x2. So now we write here x2. This one guys is going to be equal to k e raised to negative 4t like that. So guys, this is the format, the equation that is used to get our particular integral, and this is a result of having e raised to negative 4t. So guys, we introduce a constant there, which now we are going to find out what is that constant, and we do that by differentiating now x2, that is dx2 all over dt. This one now gives us negative 4k e raised to negative 4t. We go ahead again guys, we differentiate yet again d squared x2 all over dt. For this one guys is going to give us now 16k e raised to negative 4t. Guys, now as before, we had equated our equation now to 0. For this time, guys, now we are going to equate our equation now to e raised to negative 4t. And now we also replace for the d squared x all over dt. Maybe I can write, or I can show you that. Guys, now we are going to replace this, what we had written here. We are now going to replace for the dx squared all over dt. Guys, we replace with this, and for the 4, we are supposed to replace with that, and for the x here, not for the 4, but for dx dt, and for x here, we replace with that. So guys, that's what we are going to do right now. And so guys, we are going to put d squared x over dt, we write 16 k e raised to 4t like that, plus now we come to 4, and then we replace with that. That is going now to be negative 4 k e raised to negative 4t like that, plus 3. We replace that with x2, that is k e raised to negative 4t. So guys, all that is going to give us now this solution here, that is e raised to negative 4t. Guys, now we use this equation to get our constant k. This is our constant k. We use this equation to obtain that. And guys, we do that by using the coefficient, so that all the coefficient of e raised to negative 4t should be equal to 1, just as here we have 1. And so therefore guys, we are going to have the coefficient for this term is 16k. The coefficient for this term, guys, is going to be now negative 16k. That is coefficient of e raised to negative 4. For e raised to negative 4 here we have 3. So this is plus 3. Guys, this should now give us 1. And of course, guys, now as you can see, we can cancel that and that. Here we have k like that. And so guys, we are left with the k is equals to a third. And guys, we are now able to determine, we have determined our k in this equation. And so guys, after that, after we have replaced for x, that is k in this equation, this is our solution for, that is, particular integral. And formerly, guys, we had this other solution, which is x1, and we found out that our solution was that. So now, guys, we just come and combine both of them, even as I have done here. So guys, I've already combined both of them, and so therefore this is now equal to x. So x is equals to that. This x1, x2 equals to x, that is particular integral and complementary function. So our solution now is supposed to be this, plus, that is plus now b e negative 3t plus a third e raised to negative 4t. So guys, our work now is to find what is a and b, and that's what we are going to do. So guys, we come here and differentiate again. Here we say dx all over dt. This one now gives us, so guys, we are doing this because here is our conditions. We have t equals to 0 when t is equal to 0, x equals to 3, dx dt equals to 4. So guys, this is our conditions, and when you fulfill that conditions, guys, we shall be able to find what is a and b. So guys, we first of all differentiate that, and we are going to get it as, this is now going to be negative a, like that, e raised to negative t, plus this one is going to be negative 3b e raised to negative 3t, plus this is now going to be negative. This is going to be negative 4 all over 3 e raised to negative 4t. So from there, guys, now we can now come and put in our conditions. Remember, our conditions are for dx dt, which is this, and also for x equals to c to 3, which is this equation. So we have these two equations that we are using to check on our conditions. So guys, we can start off, and this is how we are going to start off. We are going to replace our value t equals to 0. Now guys, using this equation, we are going to have, first of all, this is going to be 3, x is equals to 3, equals to, now we replace t with 0. Once you do that, any number raised to 0 is usually equals to 1. So this is going to be a, plus, we come here, we replace again. Once you do that, guys, we also going to get b. And then when we come here, guys, this is now going to be a third, like that. Now guys, coming to the second, which is now for the x dt is supposed to be 4. We come and now replace the numbers again. For this, you get negative a. This one we are going to get negative 3b. And lastly, guys, we are going to have negative 4 over 3, like that. So guys, after doing that offline, my answer is b equals to negative 4 and a equals to 20 over 3, like that. And so guys, our solution then is going to be, according to this equation, is going to be x equals to a is going to be 20 over 3. So we put 20 over 3. Maybe I can bring it closer like that. We put 20 over 3 for a, 20 all over 3. That is for a, e raised to t, negative t, And then we have plus b, which we are saying is actually negative 4. So this is going to be negative 4 e raised to negative 3t, and finally we have plus a third e raised to negative 4t. So this is your solution, guys, for that equation. And so guys, thank you for listening to me. Bye bye.